We have Paul back here from Pulumi with us. Hi, Paul, are you here?
I am here, yes.
That's nice. Yeah, so people are still coming in. We have 37 people right now in the Google Meet call. We have the same amount of people in our YouTube stream. Let's give everyone just a couple of more minutes to get into the room, and we will start afterwards. Meanwhile, if anyone wants to say hi or say where you are from, where you are tuning in from, feel free to unmute yourself and greet everyone here. So hi, I'm Karen, one of the admins here in the community, and I'm near Nuremberg.
Hi Karen, I'm Pradeep from India.
Now, for the first time from India, because we know that Pradeep, our senior member, moved from Germany just a couple of days ago to India. So yeah, welcome to India, back to India.
Thanks.
Hi everyone, I'm Ravi from Kuala Lumpur, Malaysia.
Hi, Ravi.
I'm part of the community since long time, I think almost a month. And I got a lot of help to clear my Google Cloud Associate Cloud Engineer certification from this community. And as of now, I'm preparing for my professional cloud certification. Thank you.
You cleared already something, or you are just preparing yourself for?
I already cleared the IaC certification, Associate Cloud Engineer for GCP. I already cleared it. Now I'm preparing for another certification for Professional Cloud Architect.
Nice, nice. Congratulations.
Thank you.
Yeah. Hi all. This is Amara from India. So in Hyderabad. So I am working like in architect in Azure and AWS and open source DevOps and Azure DevOps. So I have completed my like in AWS and Azure in architect certifications. So now I am looking for like in the Google Cloud certification. Write the exams. So for that, like I am joining this to complete that.
Thank you, Amara.
Hello everybody, this is Bhavesh from India. I'm preparing for Google ACE certificate.
Hi, welcome. We are still admitting new people into the call. We'll just wait a couple of more minutes and then we will kick off. Meanwhile, if you want to say where you're from, you can also use your chat either in the Google Meet, we have a chat there, but also in the YouTube stream, say like, hi from Nuremberg, Germany, or wherever you are from. We have this nice tradition in our community to greet each other, you know, at the beginning of study jams or webinars or something like this, just for a quick time, you know.
You have quite a range of time zones here. This is quite impressive. From Malaysia to Florida.
Absolutely, Paul, you know, and it's this time is not an it's a scientifically chosen time to cover the most of the time zones in the world. And it's very, very convenient also for Europe because it's 4 p.m. right here in Germany. In England, it's 1 hour less. But yeah, it's evening in Asia. It's early morning in Americas. But this way, with just one webinar, we can cover the whole world. Imagine that.
Yeah, that's very impressive. I also actually see we have an attendee from Ethiopia. This is my first webinar for an attendee from Ethiopia, so that's quite impressive.
Yeah, we have like people from all kind of exotic places as well. Like, but Africa, Africa is very conveniently, it's almost the same time zone as Europe. So whenever we run something here in Europe, people are joining from African communities as well. We already have several this kind of events with African communities as well. Okay, it seems like everyone is warmed up now. I would say we can officially kick off our meetup today and our webinar. I want to welcome Paul again. Paul Stack is from Pulumi, tuning in from England, I guess, right, Paul?
Ireland. I'm in Ireland.
Okay,
yes.
nice. Great.
Same time zone. So you're correct.
Okay, great. Yeah, so Paul, we don't really have any agenda today. It's everything like up to you and our community members how we design it, but you will drive this whole webinar. If you could just introduce our members a little bit to Pulumi, what kind of company is it? How long is it on the market? How big is it? What are you guys doing? We are very excited here to hear this story as well. Not just the webinar itself, but I heard from some of our members that you have really amazing products in your portfolio and solutions, and we are of course eager to learn more about these technologies as well.
Excellent. So thank you all for joining my webinar. As Karin said, my name is Paul Stack. You can find me on Twitter at Stack72. You can find my email address, paul@pulumi.com. I'm one of the engineering team at Pulumi, so I am not a salesperson. This is not a sales pitch. What I will show you today is everything is open source. Everything is available to use free of charge. And you can then start to integrate it as you need to within your organization. So Pulumi is a relatively new infrastructure as code tool. And when I say infrastructure as code, I actually do mean infrastructure as code, because everything I will show you today will be written in TypeScript, which is a JavaScript subset. But you can also do the same thing with Python, with Go, and any of the .NET languages, so C#, F#, and VB. So we actually do support real languages, not JSON, not YAML, not DSLs. And we've been around for about, we've been an open source company for about 1.5 years, maybe slightly longer. We recently hit 2.0 as our version. So our claim is that we're trying to follow real strict SemVer style scenarios where we version our APIs correctly and we ensure backwards compatibility. And what we're trying to do is we're trying to provide an experience that allows to bring infrastructure engineers and developers closer together rather than the current silos that they have because of the separation of skills. And as we go through, I have a lot of demonstrations today. I see that there's a question, how is it different from Chef and Puppet? It's extremely different from Chef and Puppet because it is not a configuration management tool. It is much more around the life cycle of resources rather than just interacting with resources themselves. Of course, in Chef and Puppet, you can actually spin up and create resources and manage them, but they're much more termed to be like a longer life style scenario system. So we'll go through it and we'll show you the differences as we go through, and hopefully the demos will be able to demonstrate what's going on. So it's important to say, as was noted on the meetup, there is a prize for my favorite top 3 questions today. We will ship you a T-shirt, which is a T-shirt of our logo, which is called Pulumipus, and he's a platypus, and it will allow you to hopefully just interact with the session a little bit, so that you can actually get something back from it. So we are in the era of the cloud transition, and even more so since all the craziness that has been happening in the world because of the COVID-19 scenario, and a lot of companies are starting to accelerate the types of situations and move into the cloud faster. We've identified that there are usually 3 different versions of people's cloud transition. So version 1, which is much more the first wave, you're experimenting with the cloud the first time, you're trying to get up to speed with what's happening in the cloud, and you try usually and replicate what's in your data center or what you had in your data centers. So it's mostly N-tier style architectures where you have a number of web servers and a number of database servers, and they sort of sit in a management sort of style scenario that they're longer lived. You would probably use a configuration management tool, Chef, Puppet, Ansible, SaltStack to manage them. And they're much more longer lived. You care for them a little more. They're not as ephemeral. Okay, and that tends to be like people's first foray into the cloud. Then you have V2, which is a transitional style scenario. And the transitional style scenario sort of allows you to take advantage of a little bit more of what's happening in the cloud. Maybe you're taking advantage of containers and VMs, and that you're maybe trying to take advantage of like cloud native solutions like Google Spanner or Amazon RDS or one of these different types of things. And then you're starting to integrate like monitoring tools and like Docker and all these different pieces. So, you're starting to experiment a little more in the cloud as you go through. And then we have what's called V3 style architectures in the cloud. And we probably refer to these today as like cloud native style architectures. And when I say that, I mean like, microservices based or SOA based. You're probably taking advantage of something like Kubernetes and or an orchestrator for your containers. You're definitely interacting with like storage engines and maybe taking advantage of like functions and machine learning and all these different things. And it really becomes hyper connected and fully connected. There's a range of tools that like support all of these different scenarios today, but we at Pulumi, we actually are trying to like give you that V3, that modern style architecture out of the box, because real programming languages allow you to create logic and take advantage of actually programming ecosystems in order to actually help you achieve it. So it's important to say today that we're talking about infrastructure as code. And when I say infrastructure as code, it's getting rid of that manual clicking around in a console. Okay, so you're automating the provisioning and changes of your infrastructure. You're gaining the visibilities of what you're trying to do via code reviews and previews of what you're actually building. It's automated, it's repeatable, so therefore it is immutable. It's not immutable. It's idempotent, I apologize, so that you can run the same commands again and again, and it's not going to change anything because of the fact it has an end state. And of course, that gives you the ability to have safe and predictable changes. So once you know that that's what our infrastructure as code, I just want to bring everybody up to speed with what I'm suggesting, what we're talking about today. But Pulumi, we believe that we're giving you modern infrastructure as code. So when I say that, like, there's a flow. There's the create, the deploy, and the manage.
Sorry, Paul, can you unmute yourself? I think we have some funny people who muted you. Sorry for that.
Can you hear me now?
Yeah, we can hear you now.
Where did I get to?
About 20 to 30 seconds ago.
Oh, okay. That's fine. So we're trying to bring this idea that you can have this real sort of software development flow as part of your infrastructure as code. You can use your IDE, your testing tools, your packaging tools, all of the frameworks that you use on a day-to-day basis. You can actually create the layers of abstraction that you would be used to building as part of your software. And that allows you to take advantage of the real languages that go with things. Of course, then you have the CLI style scenario for building and for deploying and getting your preview of your changes, which allows you to integrate into your CI/CD workflows. And then lastly, because we are an actual infrastructure as code tool, we have to offer you the ability that you can see all the audit trails of all of the changes and the complex scenarios that have happened, and then even implement like policies and controls about all the different pieces that's going on. When we actually talk about infrastructure as code, because of the fact that infrastructure as code is usually using YAML and JSON and DSLs, Pulumi are starting to introduce this idea where we're introducing infrastructure as software. So you can use your semantic versioning, your testing pipelines, your code reviews, your pull requests, your chat ops, all of these pieces in order to build this entire cluster of your infrastructure, and you can actually do it in a real collaborative way in a style that would actually work as like in your same development workflows. So for us, we have a number of layers that we're building upon. Okay, so right at the bottom we have providers, and there are a number of providers that are available today with Pulumi. I believe there's in the region of about 43 or 44 providers. So of course we support all of the major clouds: AWS, Azure, Google Cloud, Packet, Ali Cloud, DigitalOcean, VMware, OpenStack. We support a number of tools like New Relic, Datadog, Cloudflare, NS1, and then we have actually very good native interaction with Kubernetes. On top of the providers, we can actually demonstrate how we can build libraries or patterns around containers and serverless and infrastructure management that actually allows you to create simple, very easy to work with APIs that you can share amongst your company. And then even on top of the libraries, based on the libraries that we create, we are starting to build frameworks around best practices for building and simplifying how people actually do things to the cloud. So an example here would be, if you know Amazon, I haven't got a similar demo in GCP right now, but if you know Amazon, to create a VPC, you need to create the VPC resource, you need to create the subnet resources, you need to create the internet gateway, you need to create the routes, the route tables, the route table associations, and the NAT gateways and the elastic IPs, and it's a lot of boilerplate code just to create a VPC. Pulumi have managed to create a framework that allows you to build that in a single line of code, and it's all of the complexity is hidden away, which you can actually start to use within your company to build your own frameworks and your
Paul, you're not audible right now, just for 5 seconds or so.
I really wish people would not mute me because I can't see it. Actually,
Does anyone know who is muting the people?
I'll move it to another window. It's fine.
Okay.
Okay. There we go. You should be able to see my screen again. Yeah?
Yeah,
excellent.
yeah.
Okay, cool. So Pulumi allows you to deploy code from anywhere to anywhere. So we hook into all of the major source code repositories. Okay, so GitHub, Atlassian, GitLab, VSTS. As I said earlier, you can use specific languages like JavaScript, TypeScript, Python, Go, C#, F#, VB. You can even, if you really need to, create your own language bindings around it. We have CI/CD pipelines, which allow you to hook into PyP, NPM, GitHub packages, Spinnaker, Jenkins, CircleCI, GitHub Actions, CodeFresh, Travis. And then, of course, we can deploy to AWS, Azure, Google Cloud, Kubernetes, VMware, so on and so forth. So it really allows you, because we're using the language ecosystem, to create this ability to create and deploy from anywhere to anywhere. Now, it's very important to suggest and tell you right now that Pulumi is a declarative syntax. Even though you're using a real programming language, it is end state. What you declare in your Pulumi application is what will be deployed to the cloud, okay, to your cloud or your clouds of choice, okay? So how you get there is via imperative programming. We can, of course, then, because we're using real languages, take advantage of native programming constructs around loops and around maps. In this case, you'll actually see that we're going to provision a number of instances if we have defined a count in our configuration.
Paul, we are not able to hear you.
Okay, yeah, I can see somebody muted me again. Yeah, in this case, we're able to see that a Google Container Cluster can be deployed in the same infrastructure project as the Kubernetes namespaces and the applications and the deployments and the services that go with it, because we have the outputs from one resource able to be inputs of another resource. We have reusability. You can actually package up your own code, your own systems, and you can actually share those around in your internal company package managers. So like, as I said before, NPM or PyPy or NuGet if you're a .NET developer, and you can share it around, and your developers or your infrastructure engineers or ops people, they can start to take advantage of using what they know, writing code against specific APIs or packages that they've actually developed themselves. And then lastly, or not lastly, but one of the main features that we have in Pulumi is that we have advanced orchestration. So this is the important one, okay? Pulumi will allow you to ingest code that is already on the internet, or make calls to APIs, or ingest SDK packages that already exist. In this specific example, we have an application deployment of Kubernetes, and we're going to deploy 3 replicas of that Kubernetes deployment. When we deploy those 3 replicas, we're actually making a request to check the metrics from our Prometheus configuration. So P8 is a Prometheus library that you can actually go and you can talk to, and this is code that's been hidden away and written in a specific way. And once that actually comes back with a true or a yes that works as expected, it will then allow you to continue the deployment of the rest of the replicas inside our Kubernetes cluster. Usually what would happen in a blue-green style deployment like this, or a canary deployment like this, is that you would have to run the first deploy, then you'd have to go and talk to another tool, then you would then go back and run the deploy again, and you would keep doing that until you actually deployed all the applications in the cluster. Real code allows us to do this very easily from Pulumi within the same application. And one of the features that came in 2.0, and we refer to as one of our superpowers, is the ability to actually really test-driven develop your infrastructure. And when I mean test-driven development, I mean test-driven in the true sense of the word. We can actually mock the requests and the responses from the cloud, and we can actually get those requests and responses in our code that allows us to start to test the real logic of the infrastructure code itself. Now, usually what happens is that people would deploy the resources to the cloud and then check after the resources have been deployed if the code worked as expected. And of course, when you're starting to take advantage of long provisioning times, that starts to make the feedback loop for the development team or the infrastructure team very slow. So we thought it would be a very good thing that we could actually mock those interactions out, and I can show you an example of how that actually works a little later. My favorite thing about Pulumi is secret management. We are bad at secrets in IT. We think we're getting better, and we are getting better, of course, but security is something that we don't really think of until the last minute. And I know that there are a lot of security or IT sec or DevOps sec people out there who would love that this was actually a first-class thing as it goes through. But we actually give you a secret engine built into Pulumi. And it hooks in with all of the major clouds and HashiCorp Vault. So it's AWS Key Vault, Azure, AWS KMS, Azure Key Vault, and Google Cloud KMS as well, HashiCorp Vault. And if you don't specify that you want to use one of those, you will actually use Pulumi KMS, which uses the Pulumi SaaS itself, and it talks to Amazon KMS under the hood. So we try and enforce it by default so that you are able to encrypt any piece of information that you need. And you can actually see that when we Pulumi config set a database password or a username or something like that, we can actually specify it's a secret using the -- secret key, and that will actually allow you to encrypt it the whole way through. And I'm going to demonstrate that so you can see what's going on, and you can actually see that in action as we go. So how does the architecture of Pulumi work? Pulumi is a CLI. Therefore, the credentials for your cloud need to be very close to where the CLI is held. So Pulumi will read it via environment variables, or it will read it via configuration that is passed to the CLI. It will then talk to the cloud of your choice. So AWS, Azure, Google Cloud, it'll talk to Kubernetes. You can even make it talk to vSphere, OpenStack, Azure Stack, all these different things. And only then will it store the state. By default, it stores the state in the api.pulumi.com, the Pulumi SaaS. Okay. Now, of course, there is no connectivity from the Pulumi SaaS to your cloud. So we do not need to store your credentials. Not only do we not need to store your credentials, we do not want your credentials. So please don't try and like hard code your credentials in there. You can swap that out at any point so that you don't need to use the Pulumi SaaS, and you can log into a cloud URL backend. So you can actually store your state in a Google storage bucket. Okay, so, and again, that will work in exactly the same way. As long as the CLI has access to store the state in your bucket, then at that point, it will actually interact back and forward as it needs to. And there will be no interaction between your bucket and any data that is stored in your bucket and the cloud of your choice or where you're deploying your resources to. So let's actually go and start like having a look at some demos so we can actually see what's going on. I'm going to take a second just to have a look at some questions, answer some questions as we go through here. Because it's a good time to break here. So there's a question is from Sampath. It says, Paul, I am not a developer. Is it still possible to use YAML in Pulumi? So the answer is no. So all Pulumi resources by default are actually real programming constructs, but we believe that the programming constructs are not really overly complex, that it would stop you just because you don't have, like, you're not a developer, and I'm going to show you that that's actually the case. Kevin Everall said, is it similar to the new version of Terraform that has an SDK? Yes, it is similar, but it is different enough because the Terraform CDK actually emits Terraform under the hood. Pulumi does not emit any intermediate. It actually will natively interact with your cloud as we go through. Uni said, do we need programming skills in order to start with Pulumi? No, we do not. And I will show you that that's actually the case. But of course, as you're learning Pulumi, you can learn programming skills about it. Okay, so I'll stop here and I'll continue going forward and I'll show you some demos. So I'm hoping everyone can read this. So Pulumi is a CLI tool. If I run the command Pulumi, then you will see everything that it needs to give with. And it says to begin working with Pulumi, run the new command. Okay, so Pulumi new will actually create a new program or a new project, and it will offer you a number of choices of what you're actually trying to do. So if I say Pulumi new, what it will do is it will give me a list, an interactive list of what I want to do. So AWS C# or GCP G#. Today, we're just going to create GCP TypeScript, okay? So it will ask for a project name, okay? And I'm going to say, webinar 1. And it'll ask for a description if you want to be descriptive about what you're actually trying to deploy. It'll ask you for a stack. So it's important to talk about stacks here right now. So a stack is the ability to separate the deployment of the same resources. Okay, so let's pretend you have a Pulumi application that deploys a GKE cluster. It deploys a service account that goes with it, and then it allows you to interact with the GKE cluster. You may want to deploy that infrastructure multiple times. So I mean a dev stack, a testing stack, a staging stack, a production stack, and we can segment them away from each other. So each stack will use the same code, but you can independently release, create, destroy from each other's stack. Okay, another way of thinking of stacks is each developer can have their own stack. So developer 1 can bring up exactly the same stack as developer 2 and actually not cause problems in developer 2 when they're actually interacting with each other. Today, we're just going to say dev because it's for a demo. And then it'll ask me for the Google Cloud project that we want to deploy into. So I'm going to say Pulumi GCP, Pulumi CI GCP provider. And then it's going to scaffold an application for me right now. As you can see, it's downloading some things from the internet. And it installs everything that it actually needs to do. So let's go and have a look at what this does. And here's our code. So as you can see, I'm going to go into presentation mode. As you can see, it creates a number of things. Okay, so the first thing it does is it downloads all of our node modules and everything that's in there, all the dependencies, a git ignore, a package lock, a package lock.json, a pulumi.yaml, which basically specifies the name of the project, the runtime that it has, a description that's there. It has a pulumi.stack.yaml. So we chose the dev stack, so it's pulumi.dev.yaml, and we'll see that it has a configuration object, which is a project for your Pulumi CI GCP provider, and so on. But the most important thing is it actually creates an index.ts, and this shows you the most basic deployment within for a Pulumi application on GCP. Now, what this actually does is it will create a Google Cloud storage bucket named My Bucket, and it will export the URL of the bucket back so that we can actually see what it looks like from the cloud. And if I run the command Pulumi up, the first thing it'll do is it'll give me a preview of everything that it wants to do. So you'll see firstly, it's going to create the stack, and then it's going to create a bucket. And we can have a look at the details of what it is going to do. And we can actually see that the bucket is in location US. The storage class of the bucket is standard because these are defaults that happen as part of the provider. But the interesting thing here is it says the name is my bucket dash and then a random string. So I'm going to say no, and I'm going to talk to you a little about this. So by default in Pulumi, a Pulumi resource has 3 parameters in the constructor. It has a name, which is used as part of the state. It has some arguments, so bucket arguments, and then it has some custom resource options, which we'll talk about a little later. By default, most Pulumi providers will use the name that is passed to keep in the state as the name of the resource that you are actually deploying, but we will add a random string to the end. We believe that there are lots of scenarios where you have to create new infrastructure before you destroy old infrastructure. And because of that, there are specific scenarios that you cannot deploy the same thing with the same name twice. A bucket is a perfect example of that. You cannot deploy the same named Google storage bucket twice. It just does not work. It's a globally unique name. So adding a random string on the end is actually quite useful in this case for us. But we can override that. And we can actually turn it off, and we can say name equals webinar. Actually, if I just say stack72 webinar bucket. And I go back to Pulumi, and I run Pulumi up again. And again, it will tell me the preview of what it is going to do. And we can see two items to create, the stack itself, because it doesn't exist yet, and the bucket. And we can have a look at the details, and you will see that it has enforced the naming that you give it of stack72 webinar bucket. So we have overridden everything that is in there around the auto naming that goes with it. So let's roll that out, and let's actually see what it does when it actually goes out. So the first thing we can see is it's creating them in parallel, because it understands that it can create them in parallel. And the last thing is we get a URL back that is our Google storage stack72 webinar bucket. So let's have a look at the other arguments that go with this so we can actually change it. Let's change the storage class. And the storage class that we are going to change it to will be archive. Okay, so if I say storage class, now you can see immediately that I'm getting hints from my IDE, the autocomplete that's actually helping me do this. And I go back to Pulumi up, and the preview it will offer me will tell me that it's going to change the storage class of the bucket. You can see it's an update because it's a diff of the storage class, and we can have a look at the details, and we can see we're changing the storage class from standard to archive. Right now, it's a promise because we don't know if GCP has to recreate the bucket or if it's going to keep the same name. So we can say yes. And we can see it's just updating the bucket name, the storage class. It's updated. Only one resource has been updated, and the bucket name is the same. Now, I can have a look at any point of the state. The state is not held locally here. It is held in the Pulumi SaaS by default. And we can actually see everything that has been deployed as part of the bucket. We can see it has an ID, it has a location, it has a name, it has the project that's going with it, it has the specific storage class, and so on and so forth. Now I can say Pulumi destroy, and it will tell me what it is going to destroy. Now I have a very large Google Cloud project here, and there's a lot of different buckets in it. But as you can see, it's only going to delete the bucket that I specified, the GCP storage bucket, and then it will delete the stack that goes with that. So let's say yes. And we can see that it has been deleted. And my next Pulumi up, because of the fact that it has been deleted, will show that it has to be recreated. So we can say no. So that is the basic life cycle of a Pulumi application. So let us write some more interesting code. So let's think about creating some web servers. Okay, so I'm just going to delete this code right here. And I'm going to say, first thing I'm going to create a network. And network is held in, it's a compute network. So we can see gcp.compute.network. And we're going to say webinar network. And we actually need don't need anything else that goes with the network because we're not trying to make that any better. Let's create a firewall as part of that network. Equals new gcp.compute.firewall. We can again say webinar firewall. Now, firewall, as you can see, does require some parameters because there's nothing for arguments that's in here. So we can actually say, now what does arguments need? It needs network. Okay, it doesn't need anything else. So we can say our network will be network.selflink. Okay, just because I know this from the documentation. I've written this a lot of times. And we actually need to allow some ports into our network. So allows is actually, we can see it is an array of firewall allow input or firewall allow, and that takes ports and protocol. So we can go back and we can actually say protocol is TCP, and we can say ports Ports is an array, so let's give it port 22 and port 80. Please don't ever just give random machines port 22 and port 80. Let's think about the security ramifications. But for the purposes of the demo, this will actually work as expected. So I have a tiny small snippet of code that I've pre-created here. This is going to be for Nginx so that we can actually push some Nginx code to our server, so that we'll actually see that the server runs as expected, and then we can continue on as we go. So we need an address. It's a gcp.compute.adder or .address, and here it's going to be a webinar address. Make it nice TypeScript as we go forward, and then lastly we need an instance. Okay, so new gcp.compute.instance. Now, as we're going through this, you can actually see, let's take this instance off. So we try and segment everything as expected. So we have compute, container, config, service account, service network, IAM, projects, deployment manager. We try and actually keep things into sub modules so that you can actually understand like the different areas in which we're trying to like space all of the resources, because that's where they fall within GCP itself. So webinar, and now we can actually start to build out. So the first thing we need a machine type. We're going to say F1 micro. And then we need a boot disk. A boot disk is actually an object here. And it needs initialize params. Initialize params is also an object that goes with it. And that actually needs a name. So I have pre-created, I understand the name that it needs straight away. After the boot disk, we need some network interfaces. Network interfaces, it can have multiple network interfaces, and you can see my IDE has immediately said, yes, it is as expected here. And because it is as expected, I'm now fulfilling the API that actually needs to happen. But of course, we need to give it an interface here. So the first thing is we want to give it the network ID. And then secondly, we want to give it the NAT ID, like the address that we actually created above. But of course, you can give a list of address configs as we go. So if I say NAT IP, and the NAT IP will be adder.address. Okay, and then the last thing is we want to give it a metadata startup script. Metadata startup script will just be the bash that we wrote up here. So all it's going to do is it's just going to provision a server and use the metadata startup script to install Nginx, and we should actually be able to see Nginx as we come through. Now, of course, to get the information back, to get the IP address of what we're trying to achieve, we can export it. So if I can say export constant instance IP equals instance, excuse me, it's adder.address, because we know that we have passed adder.address to the machine to act as part of the network interface so that it connects to that. So if I say adder.address, and then we can just export constant machine name equals instance dot name, just so we can see what's going on. So there's a few different pieces going on here. And if I run Pulumi up, we'll actually see that it's going to do a number of different things here. So first, it'll create the stack as it said it would before. Then it's going to create a network address, a firewall, and an instance. And we can have a look at the details of everything that it's going to do. You can even see that it's passing in the correct metadata startup type. It's got the correct boot disk parameters because they happen by default. It has the correct priority on the firewall rules and so on. So let's let this roll out, and we can actually see what it's going to do. Now, this is very interesting because the first thing we didn't determine a region in which to create our instances. So Pulumi is giving us immediately an error as it failed as it was like building the application. And what we will do is we will go back to our pulumi.stack.yaml. And we will say GCP region, and I'm going to say US West 1. And we'll just let this fail in a second. And we can, of course, tell Pulumi to stop because of the fact that it doesn't need to go away. And there we go. You cannot determine a region, set it as a provider, region, or zone. And at this point, we can then rerun Pulumi up and it will have the correct region to deploy into. I apologize for that. We can see that it's going to create, it has to still create the address, the firewall, and the instance. And we can say yes as part of that. And it will create these as expected. It won't take long to create these pieces of information, but now you can see it's creating the address and the firewall at the same time because they're independent of each other. And then after that, it can actually create the instance as part of it. Now, of course, an instance also needs a zone. So we can Pulumi config set GCP zone, and it will be US West 1A. We want to deploy into US West 1A. Now notice Pulumi has given us all the hints of the configuration that it actually needs as part of this, so that we're actually not in this scenario of what is the error, what do we still have to do. The last thing here is we just need to deploy the instance because everything else is actually up and running as expected. And we even have an instance IP that will be attached to the instance. And an F1 micro is actually pretty fast to deploy. It'll just take a second more. There we go, it's created. Now, we can curl Pulumi stack output instance IP, and it will actually take the output of the instance IP and it will make a curl request against it. Here, it's in this case, it's actually not going to give us anything back because the instance is not yet available. And I can put that under a watch command. And very shortly, we should actually be able to see that we have an instance up and running. So we'll come back to that in a second. Okay. Now, let's make it a little bit more interesting. Okay. What happens if I actually want to create a number of web servers here? Okay, so this is where I like that TypeScript is actually quite useful here. So we can say let IPs equals an empty unbounded array and let host names equals another empty unbounded array. And then we can actually take advantage of a for loop. So we can say let x equals 0, x is less than, let's say, 5. And we can say x++, and we're now in a programming loop. Now, we can take those two resources, we can push them in, but we need to do a little bit of change in here, right? These are completely new resources. So every resource inside Pulumi needs to have a unique name. So we can say $X. So we have a webinar address 0, 1, 2, 3, and 4, and then we will have instance 0, 1, 2, 3, and 4. Now, for anyone following along, this is the programming skills and requirements that you would need in order to get up and running with a loop. And as you can see, it's not something that is insurmountable. It is something that you can actually take advantage of and build. And then lastly, what we can say is ips.push, and it'll be adder.address and hostnames.push, which will be an instance.name. And then we can change those to be instance IPs, and it'll be IPs, and machine names, which will be host names. Now, it's important just to check. We can see that we have an Nginx page up and running from before as expected. So we have been able to deploy our web server, and of course we can then do everything that we need to manage that web server. So now if I run Pulumi up, it's actually going to tell me it's going to destroy the old address and the old instance because I have renamed the resources, and that's really important. Resources are they need to have a long-running naming convention. And we can see it's going to delete 2 instances, but notice it's going to create the other instances first because we always try and have a create before delete scenario, and we can see it's going to give us a summary of actually what it's going to do. So let's say yes, and straight away it's going to create all of the addresses in parallel. And as soon as it creates all of the addresses in parallel, it will also create all of the instances in parallel to go with them. There we go. And you can see all of the instances now being created because of the fact that they're able to be done in that specific direction. Now, this will just take a second again. And we can see all 5 are created. And now we're going to delete the old ones. And notice the instance needs to be deleted first because there is actually a relationship from the instance to the address because of the fact that the network interface is actually in use here, the NAT IP. So you cannot delete a resource further up the stack because it is actually in use already within the system. So it's deleting the instance, and as soon as it deletes the instance, it will actually delete the address. And it should finish any second, please. Come on. Hopefully. It's a little slow. I apologize.
No worries. What backend is it right now, Paul? Like what cloud provider are you using?
So I'm actually using the Pulumi cloud.
GCP, right?
In fact, I can.
Okay.
Yes, it's using Pulumi. It's talking to GCP, of course, but it is talking to the Pulumi cloud. So if I show you what it's actually doing in here, if I just say GCP, a webinar, I think I called it. Hold on, what did I call it? GCP webinar. What is my project called? Oh, webinar 1. Yes, it is webinar 1. Okay, so webinar 1, you can actually see the stack that's there. You can see the instance IPs, you can see the machine names, the project configuration, other specific tags that go with this. The current activity, you can see all of the failures that go with this. You can see the changes that happened, the resources that are actually in place. Of course, it'll link out to Google Cloud as part of that. And some specific settings. Now we can see that they've all finished. We all have the host names and we all have the IP addresses. So let us loop over and let's actually see if this works as expected. And we can actually say for all of the web servers in the loop, curl the instance IPs, use JQ in order to get the IP address, and we'll be able to talk to each. There's the first one, the second one, the third one, the fourth one, and lastly, the fifth one is. So we can actually see that all of the instances have been deployed there. So let's actually take this a little further right now, and let's start to refactor our code, okay? Because that's not that useful and interesting. And let's pretend that you have an infrastructure engineering team who try and create like these APIs that you actually need to. So the first thing we're going to do is we're going to create a web server.ts, and we need to import star as GCP from Pulumi/GCP. Oh, excuse me. And we're going to create a class. So export class. Let's call it an Nginx web server. Okay, because we can create this level of abstraction. We can even like create other levels of abstraction using inheritance because we're in TypeScript, but this will work fine. So this will return a read-only instance. The instance will be of type gcp.compute.instance. And we will also create a public read-only instance address, which will be a Pulumi.output. which will be of type string. Now we're starting to get a little more into the internals of programming as part of Pulumi, but of course, this is only shows that you can refactor to advanced usages. This is not actually how you would have to do it as you go. So we can have a constructor. Oh, typo, I apologize. The constructor would have a name, which will be of type string. It will have a machine type, which will also be of type string. It will have an image name, which will be of type string. And then it'll have a network, okay, because we need to pass in a network. And just to show the fact that we're using real programming, we can pass the entire network object around inside in Pulumi, and that way we can take advantage of what's happening. Okay, so let's go and grab some code from before. Let's take this bash script because we don't need it. We can actually push it because it's an Nginx web server. We can push it inside the Nginx web server. Let's create the constant of address equals new gcp.compute.address. And the address we can actually give the global name that we've passed in. And then lastly, we can say this dot instance equals a new gcp.compute.instance. The instance will be of type name. And then we can start to take advantage. So I've pre-created this in here. And I'm just going to copy and paste it. We can see the machine type we're passing in as a string. The image we're passing in as a string. The network we're passing in as an object, so we can use the ID. The address has been created in the same scope, so we can use address.address. And the script is also created as part of the class. And then, of course, we need to export the instance address. And we can say this.instance address equals address.address. Now, it's important to say here, Pulumi.output means it is the result of a resource that has been created or interacted with by Pulumi. It's the resolution of a promise. Okay, so that's why we have the Pulumi.output wrapping the string. If we change that to just string, and it would be like, no, you can't do that because it's an output. We don't know what it is. It needs to be resolved. So we wrap it with a Pulumi.output. Now we can go back to our main code and we can refactor it. So let's not do that. And what we can do is we can say, if I say constant nginx instance equals new, and if I say web server, or a new Nginx web server, now notice my ID has immediately gone and brought in the correct reference as part of that. And the name I want to say is GCP demo, actually. What did I call the other machines? Webinar. So I need to call it webinar. Okay, so let's just say const nginx instance equals new nginx web server, which will be called webinar-x. And it takes a number of parameters. The parameters will be f1 micro, as it says machine type. Notice that my ID is helping me and giving me hints along the way of what it needs to do. It also needs a network as part of it. The network will actually be the entire network that we created above. And notice the fact that it has adhered to everything that's there. Now, of course, at this point, we don't use adder and instance because they don't exist anymore. We can actually see, can't find anything to do with it. So here's, we have nginx instance address. And here we have an nginx instance, which will be of type instance.name as part of it. And we get everything as expected. Now, all we have done here is we have not renamed any resources. We have just refactored the resources behind an API. So if all goes well, my Pulumi up should tell me that it's not going to make any changes because I haven't renamed any resources. And that is not quite true. Let me just make those correct. So yeah, so in my web server, I created the address, which is incorrect. Yeah, so that's fine. It's only because I named them incorrectly the first time around. And we can actually say, yes, you can see it's going to create 5, update 5, delete 5. And it's only going to update the instances with the new network interfaces. It's not going to recreate the instances as we go through. So we can refactor the code as we need to and how it works. So this should take a second. And then we'll go on to another demo. So I don't have a long time left. I want to keep some time for questions at the end.
Yeah, great. Paul, do you think maybe in between the demos we will take a couple of questions as well?
Yeah, sure.
Okay,
Sure.
great.
So
Okay.
if you want to call them out, Karen, that might be useful if you've been keeping an eye on them.
Yeah. We have actually Slido going on as well. I can share the link with you.
I have the link right here. I have the
Oh,
link.
you have it.
Yeah,
Great.
I have it open. So I'll start at the top of Slido. What is the best way? So I'm going to go most recent. Okay. Actually, I'll go the oldest question first. Okay. If it's by Anirban, it says if we delete the Terraform TF state file, it's a big risk if we don't have a backup of it. In Pulumi, there's no state file. So how do we mitigate the risk to delete the state? So the state file does exist in Pulumi, but by default, Pulumi doesn't give you the ability that you can delete it because we use the SaaS, the Pulumi SaaS out of the box. And we can actually see that. We can say Pulumi, who am I, -v. And we can see that I'm logged in as user stack72 to the backend URL app.pulumi.com, stack72. And actually we can say verbose. Actually, it's the same output. I changed that. So like if I Pulumi log out, and that would take me out of the back end, and then I say Pulumi login, and I say like help, you can actually see that you can log into the back end. At that point, you have a state file and you can delete it, so you would have a problem. But if you adhere to correct practices around versioning, then of course you can revert back to it. The Pulumi SaaS will not allow you to delete it. Okay. So the next question is by Nitin. When we remove and add new resources and apply, sometimes I notice that the state file becomes inconsistent. So Pulumi refresh is your friend here. And Pulumi refresh will tell you how it reconciles everything that's going. Notice these are defaults that happen inside GCP, and you can see that it's actually going to bring all of these specific new files down because they're not synced as part of the first run. So Pulumi refresh is the way of being able to reconcile your state file. Nitin also said, I have added a typo in my resource configuration. Terraform apply stopped the instance, but failed when trying to change the instance as expected. Why is there no validate? That's a question about Terraform, so I can't answer that, I'm afraid. Sanjay said, what is the best way to migrate Pulumi to Terraform, or Terraform to Pulumi? Can I take a Terraform state file and import to Pulumi? Can I create a module in Pulumi like a Terraform module? So right now there is no support for Pulumi Terraform modules in Pulumi because modules are a completely different thing. But there is a project called TF to Pulumi that will allow you to scaffold. It is a binary that allows you to scaffold an entire Terraform file. So let's say like main.tf right here. And it will actually scaffold it as a Pulumi application. So it will just like do an implicit conversion in place, but there is also the equivalent that you can run these applications side by side because we have the ability that Pulumi can read your existing Terraform remote state using the Terraform package, Pulumi Terraform package. And we can say terraform.state.remote state reference. You give it the backend type, so like a remote or a Terraform enterprise or console or anything like that. And then based on that, you can build your existing infrastructure, or your new infrastructure on top of existing infrastructure that has already been created. So there is a way that, of course, we can coexist in the ecosystem. What is the best practice to run local and local exec in Pulumi? And can I use a template like a TPL file? There is, as of July 2020, there is no such thing as a provisioner in Pulumi, but you can go to our Pulumi.examples repository and you can actually have a look at how you can take advantage of existing infrastructure. So you're just like able to import, if I show you, I apologize, the provisioners block and the index file, you can see that it's importing SCP and SSH2, and at that point you have a connection to a machine, and when you have a connection to a machine, you can actually do everything that you require it to do. So in this case, this is copying files up to the remote machine. This is remote exec to the remote machine. Pulumi at this point doesn't have support, as I said, for provisioners, but you can take advantage of building them yourself because you are in a real language as expected. Uni said, is a programming skill a prerequisite for learning Pulumi in Python maybe? I believe the answer is no. As you can see, I started extremely simply, like building just simple resources and then refactored as I went along. As you learn programming skills, or as you're starting to take advantage of Pulumi, you can refactor as we go and learn the new skills as you go. Then I have, this is from Suman, how does it impact the developer's workflow if someone migrates?
Paul, we have a audio problem here. We cannot hear you right now.
Somebody muted me again.
Okay, sorry.
That's okay. So we cannot migrate from one language to another very easily in Pulumi, because if we change the runtime, in this case it was Node.js, and if we went to Python and we went and ran Pulumi up, then Pulumi is not going to like that because your programming language is not Python. Okay, see, you just purely get an error because you don't even have a module that's called that's there. So you can't really migrate easily between programming languages. How Pulumi can expedite the GCP resources deployment in a complex cloud infrastructure environment. Ravindra, I'm really sorry, I don't understand the question here. I'm not going to try and speculate what that question is. Anonymous, does it have a state file similar to Pulumi or similar to Terraform that we need to back up? Yes, 100%. You need to back up your state file if you do not use the Pulumi SaaS. If you take anything away from today, that is what you should take away. Sampath said the same thing. How does Pulumi differ from Terraform? Are there any similarities? All I'm going to say here is there is.
Paul, I think the very major difference here is also that Terraform is using their own language kind of to have a configuration in place.
There's a whole page on this about actually what it's doing, how to convert, how to use them side by side. It's better to read that page, and it's a much more in-depth conversation as part of that. So I'm going to have one more demo or another couple of demos, and then I'll come back to more questions. Okay, so let's say demo 2. So let's have a look at the secrets management of Pulumi. Let's have a look at the power of what Pulumi allows you to do. So let's say a Pulumi new TypeScript application. If I say webinar 2, dev is fine. And I want to install one more package, which is the Pulumi random package. Okay, so npm install at pulumi/random. And then we can take advantage of it. So let's pretend that we're creating a secret, okay? And let's just say let's create import star as random from at pulumi/random. Okay, so let's create a random password that we can use within our resources. Random password equals new random password. And I'm just going to say demo 1. And let's say length of that password is 30 and it has special characters true. And what tends to happen with a lot of tools, if we export that const, password val1 equals random password dot result. I know that the result is stored in result. Now I can say Pulumi up, let's say non-interactive, and say yes. Let's put it in the like a CI mode to make it run faster. And what usually happens is that not only do we get the random password coming back in the UI, so you can see that's the random password that was generated, but we also have that, and it's usually like proliferated around the state file, which is of course not fantastic. So let's create a new one. Random password 2 equals new random dot random password. I'm going to say demo 2. And again, we're going to say length 30, and we're going to say special is true. But this time we're going to take advantage of, you notice we had name and we had arguments. This time we're going to take advantage of the custom resource options block. And Pulumi allows you to specify any outputs from the resource as additional secret outputs. Okay, and we're going to say we want to push result through our secret engine. And then just to show that that's actually gone through the secret engine, we can say random password 2. And we can come out the back. So if I say and skip preview, because we don't care about previews in this case, then you're actually going to see it's created the new random password, and you can see that it's a secret object. Not only is it a secret object, but it is also proliferated as a secret using a ciphertext in the state file as it goes. Now, of course, it doesn't just have to be a secret value in here. You can put length in here. You can put special in here, and we can rerun the same up. There'll be no changes that happen as part of this. And we can see in the stack export, you can actually start to see more ciphertext that happen. So you can encrypt as much of this as you want. And then the last thing is to show you around secret management. My secret root password is password 12345 exclamation mark. In my stack file, you will see that that's actually a secret value, or it's not a secret value, it's stored in plain text. But if we tell Pulumi it's a secret value, then it is a secret value right here. I could even show you that by saying constant config equals new pulumi.config. So let's get access to reading from the configuration value. And I can say export const equals x equals config dot require the secret. The secret in our case will be called my secret root value. And we should, if everything goes as expected, not get the plain text password back. Pulumi will understand that it is a secret, and it will keep it as a secret and pass it through. And even in my stack export, as part of it, you will see that we have X is actually being kept as a ciphertext as part of it. So additional secret outputs is your friend here. And it's something that is extremely useful as part of it. So I have time for one more demo. And
yeah, sounds great, Paul. Do we want to take a couple of questions in between, or should we move to the second demo? What do you think?
You can. I'll prepare for this demo. I'll change into the correct repository and stuff like that if you want to ask some questions for me.
Yeah. Okay. Sure. Let's see the popular ones. I'm reading right now Slido or Slido, however it is pronounced. So everyone, I posted it also in the YouTube stream. Feel free to use it to ask and post your questions. And if you found a nice question, you can upvote it as well. Okay, let me see. You have done a great job to reading some of them already. Here's another one. If you guys support many different ways to interact with infrastructure, is your team planning to prepare GUI platform? So basically, I would translate the question as
will we support remote execution?
Yeah, and also how many actual cloud platforms are you supporting right now?
So it is extremely easy to add support for a cloud platform. We actually are able to take advantage of the existing Terraform providers. We have written a bridge which will allow Pulumi code to bridge and get the schema of any Terraform provider. So if there's a specific provider that you need, please reach out, paul@pulumi.com, and we can talk about how we would pair on moving that provider across for Pulumi support. With regards to remote execution, as of this point in time, it is something that we're aware of that people may want. It is not something we're actively working on, but of course, if you have a specific use case that you need, please open an issue on github.com/pulumi, and you will be able to at least get like some interaction with the team about why it's very important.
Okay, great. I have another question from CD. It's will Pulumi hold states of deployment?
Yes. Pulumi will hold the state of your deployment. Like if we go into any of our stack files, so if I go back to Pulumi, that is the current list of resources that has been deployed. And you can see that it has all of the instances, all of the addresses, and Pulumi knows about each of the addresses that go with it. So even in the stack, the activities, if I show you the details that go with this, then we can actually, like, there's going to be like the diff, the diagnostic view, everything is in there. Pulumi is aware of what resources are currently under management.
Okay, great. Yes, and I think we can move to the next demo.
Okay, so Rajesh also said, is there any workspace concept? A Pulumi stack is a workspace. Think of Pulumi stack as a workspace, the separation of state from each other, okay? Because that's quite in the same wheelhouse. Okay, cool. So let's look at what we're going to do here. This is one of our existing demos that that is currently in our Pulumi examples repository. And it will take an existing application, okay, and it'll do two things. Firstly, it'll deploy an existing container that actually sits in the Google Cloud Registry and deploy it as a Cloud Run service. And then secondly, it will build a custom Docker image, which sits here locally. Pulumi will act on behalf of Docker, or act with Docker on your behalf. It will upload that to the specific GCR repository. So you can see it right here, GCR IO, the project name and the image name and version 1. It will build everything that's in the application folder, and it will deploy that specific container, which you build locally, as a Cloud Run service, and it will give us the status of the URL. Okay, so let's firstly, let's Pulumi stack init, and we're going to call it webinar 3. And we need to set a couple of variables. We need to Pulumi config set GCP project. The project will be as before, Pulumi CI GCP provider. We need to Pulumi config set GCP region. The region will be, this time it's going to be US Central. And then lastly, just in case it actually needs it, let's create a US Central 1A zone that goes with it. Okay, so now we need to do an npm install because we already have pre-existing code that we've written, but I want to deploy this so you can actually, see what's actually going on in here. So you can see I have Docker running on my machine, and you can actually see it's executing a Docker build right now of the app. Okay, on the preview to find out if it's something that already exists. So let's say yes. And it's doing all of this in parallel, executing the Docker build of the app. It's pushing it to GCR. It's preparing the layers. It's pushing all of the layers up that already that it needs to go. At the same time, it's going to start preparing the Cloud Run service, and the Cloud Run service will have pulled the container as part of it. And at that point, it then will run the IAM member to make it like publicly accessible. Then it's doing the second one, which will pull the existing hello application. So it's a pre-existing container, that's up there. And then lastly, it will actually give access to everyone for the Ruby container as well. And it will give us the URLs that come back from them. So if I click on these URLs, you'll see that's the first one, which is the existing hello. This is the GCR Cloud Run hello. And that's the UI that comes back from this, which is just, you've created this specific version of the application. And then secondly, we have hello Pulumi application. So let's make some changes in here. Okay, so app.rb, and if you don't specify, I could say made with love from, and if you don't specify a target, it will say Pulumi. If I say Pulumi up, again, it will it'll understand that there are changes to the container. It will start to run a Docker build again at this point. You'll see that the template is actually different. And let's deploy the container that goes with it. And it's pushing the new version of the container. You see all the layers exist. It's only the top layer that doesn't exist, and we can see it's pushed. And then lastly, it will update the Cloud Run service to pull the new version of the container. It's still going. And there's the template that's being deployed. So this is a typical development workflow. You would iterate on your container, you would iterate on your application.
Paul, you are not audible right now. Can you mute yourself?
Okay, yeah, sorry.
So it's something, I think it's a technical bug, just sorry for short interruption. We are only, there are only 2 of us in the channel right now, so maybe it's something like technically goes wrong from time to time. So yeah, bear with us.
Oh, it's gone again. Yeah, so we can actually see that it's updated the container in the Cloud Run service to be made with love from Pulumi. So this is a typical developer workflow that it would a developer would iterate on their container, on their application, continually run Pulumi up, test it in a live and inverted commas environment. And once they're happy, they would then be able to send a pull request to push it to the production environment or the test environment or the staging environment or whatever environment name you have. And that would actually be everything that's there. And then the last, I wanted to show one more. BTS, GKE, Hello World. And I'm only going to talk through this demo because it's GKE, it's a little slow. But you can go and actually deploy this. So this deploys a Kubernetes namespace and an Nginx container to GKE. So the first thing that we do is you can either specify a master version, or Pulumi will get the latest master version from the GKE API. It will specify a container with a number of nodes, the node version, the node config that goes with it, including the scopes. We can then build the kube config. Notice that we can actually do this rather than you needing to specify the YAML for you. You can actually specify and build it yourself, and it's just a YAML document. We will specify a specific Kubernetes provider, which allows us to talk directly to that Kubernetes cluster, because we specify the kube config as part of it, which means that you can deploy multiple Kubernetes clusters in the same application and specify multiple Kubernetes providers that will allow you to deploy the same code across a number of providers. We'll specify a namespace and the Nginx class that goes with it. And I guess we can actually try and deploy it. And I can ask some questions in the background. Answer some questions in the background as part of it. So let's set the zone. Let's set the region. Let's set the project. npm install. We tried to make these examples like a few configuration values and an npm or a pipey or a pip install. And now if we run Pulumi up, it will tell me what it's going to do. And we can see it's going to create all of these resources, including the Kubernetes cluster. And I have a few minutes that I can answer some questions. Okay, so do you want to ask some more, Corinne?
Yeah. Let me see. Pick just some of the popular ones. I think we already answered this one, like, do you have to know programming languages? And the question was about Python. Is it correct that you are using primarily, like, or you're recommending primarily to use TypeScript as your like main configuration language? Or you can
great question. It's a brilliant question. So the question is that, am I advocating that TypeScript is the only way to do this? Absolutely.
Was it Paul? Was it an absolutely yes or absolutely no? Because I only heard the first part.
Oh, I apologize. I was on mute again.
No worries.
The TypeScript ecosystem is an ecosystem that, you know, via npm, there's a lot of people have had exposure to, so it's very easy to demo. But you can exactly do this. Every piece of code that I've written today can be written in Python, can be written in Go, can be written in C#, VB, or F#. And it's definitely, TypeScript is not the only way to go. It's about it's about using the language that you're familiar with. A follow-up of that is, some people usually ask us, will we create a Java language binding? It is not on the roadmap for 2020, but past 2020, who knows? Like, it is something that people have asked for. Ruby has also something that people have asked for. So it could well be an early 2021 scenario.
Is it something what the community itself can contribute to your platform?
Absolutely. There is an existing pull request open that would integrate PowerShell as part of Pulumi. And that was actually a community created pull request.
Cool. This is an advantage of being an open source company, right, Paul?
Yes, absolutely. Absolutely.
Great. Do you have any other like questions which are, because it's a little bit messed now because some of the questions have been already answered.
Okay, so Kevin has asked, can I share my Pulumi IntelliJ plugin? I'm not using any Pulumi plugins, Kevin. As Pulumi is just language packages, IntelliJ just picks them up by default. So if it's a Python, if you have Python installed in IntelliJ, it'll pick up the Python package. I have TypeScript installed, so it'll pick it up, and so on and so forth. Rajesh says, is there a concept like a resource graph? Yes, there is. It is not a full directed acyclic graph because we don't need to know everything up front. It is an imperative programming language, so we will work our way down the page as we need to go. Sudarsan said, can we not adapt Terraform providers for use with Pulumi for managing infra supported with these providers? Yes, you can. There is a project which will be Pulumi TF boilerplate. And this project will allow you to scaffold any Terraform provider as a Pulumi provider using a number of just commands and like makefiles as part of it. Sudarsan said, with Pulumi, he said he sees that, or they say, I apologize, I see that the documentation is not extensive. For example, not sure where we have all the mandatory fields. Pulumi/docs should actually show this. If we say the core providers like GCP, I apologize. And let's go to compute. And let's go to a firewall. So anything with a star, it actually is a required property. It's just we don't call it out that it's required with the name required. So I apologize that that's not so easy to follow. With Terraform, we don't have to log in. With Pulumi, is this possible so that we can install and test locally without using the Pulumi SaaS? Yes, there is going to be a complete rewrite of the Pulumi backend happening very shortly. So you will not have to log in at that point. As soon as you do your Pulumi up, it will actually read from your configuration file.
Paul, just a question in between. Can you elaborate a little bit on this backend rewrite? What is the main reason to change it? Like, is it another programming language or another architecture? What you are
So
going
the
to use?
backend rewrite allows you to have different back ends between stacks. So right now, you would have to run the command Pulumi logout, or Pulumi logout, Pulumi login when you change stack. And we don't think that that's actually something that's extremely, it's not a nice user experience for people. So we want to be able to use the Pulumi configuration file where you can configure your backend in that manner so that each stack can have its own backend.
Okay, got it.
And notice this is actually deploying to, that's my my box that's my GKE cluster that has been deployed to. We can see our kube config. If we really want to, I can Pulumi stack output kube config. Let's push it to YAML. Let's export kube config to be our YAML file, and let's kube control get pods in our default namespace. Oh, I apologize. Let's kube control get namespaces first. We can see that we have a hello world namespace, which is what we have deployed to. Let's have a look at the pods, and we can Pulumi, kube control logs of that -n, which will be our specific namespace. And we can actually see that, there we go. So this is all of the launching the actual container inside our namespace, and all within the same application. So because of how we're able to control it and add it out. So I've run out of time. I apologize for running slightly over.
No worries about it. The whole time is yours. So if you're,
perfect. I will say there are a couple of great questions in here. So I would like to firstly, the first one I'm going to actually award a t-shirt to is Sanjay Parmar. So Sanjay, if you can send me an email, paul@pulumi.com, and it's for the question of what is the best way to migrate Terraform to Pulumi. What we're trying to do is create this ecosystem, create this ability that, a lot of people who have used these tools can actually be able to like move backwards and forwards and be able to use the tool that suits them. And I love that question. So thank you. There'll be a t-shirt on its way there. There's another question, and it actually came in earlier today before the webinar started, and it's from Uni, which says, are programming skills a prerequisite for learning Pulumi? Uni, if you can, please email paul@pulumi.com and I will get a t-shirt your way. We're trying to make the barrier of entry for Pulumi lower than it has been for other people. So we're always trying to make things better there. And the last one, I'm actually, Corinne, I'm going to ask you to award a t-shirt if you can. What's your favorite question out of everything that you've seen today?
Oh, the favorite question was actually my question. Just kidding. No, I don't know. Let's see. I actually also liked this migration question about the Terraform plugins, which you can kind of use out of the box almost, or I guess without almost. I kind of like this one, but we will not award two t-shirts for one question, unfortunately. Let's see. I don't know. Can you help me, Paul?
Yeah, I'm looking.
There were some great questions, but I probably just already forgot them along the way.
I guess the other question is going to be for Sudarshan about the ability to log in and log out, so around the backends for Pulumi. So Sudarshan, please, if you can, send me an email, paul@pulumi.com, and we'll get a t-shirt your way for bringing up a great discussion around the backend. So that's the three.
Yeah. Okay, great, amazing. We have the winners now. And thank you, Paul, very much for this amazing presentation. Just a short question here. If our members want to get hands dirty with Pulumi platform, what would be the best and easiest way to get started? I mean, in a kind of practical way to deploy infrastructure. Yeah.
Great question. So the Pulumi examples repo on GitHub, as you can see, has a lot of examples like for Azure, AWS, DigitalOcean. It has a lot of GCP, and it also doesn't just have TypeScript, but it has Python and Go and C# examples. There's a lot of Kubernetes examples. It's a great place to get started. It's a great place to go and understand the different things that you can actually do with Pulumi. We also have slack.pulumi.com, which is our community Slack channel. And in the community, you can come and ask a lot of questions. We have right now in the community Slack channel, we have in the general channel, we have 2,800 people. And it's actually starting to become a very interactive community. So please come along and ask any questions that you need to. And then lastly, if of course like you need to like talk about anything specific, you can send us an email. So paul@pulumi.com, and we can talk about any individual use cases that you actually need.
Great. And make sure to connect with Paul. In the description of the event, you will find Paul's Twitter and LinkedIn profile. And yeah, let's stay in touch, Paul. I hope you have your academy kind of department have some ideas about courses, upcoming courses. We as community would be totally interested in this kind of events and programs, and maybe let's catch up at some time and check what's going on there in this department.
Sounds brilliant. Yeah, there's definitely some activity in this area, so stay tuned to that area, and we will find a lot of things.